Hello all, welcome back to Sri Sai Tech Edu YouTube channel. Read, Lead, Success. I am dealing with the subject Network Analysis and Control Systems. I have already completed Module 1 to Module 4 topics and uploaded in my channel. If you have missed out, please do watch. And in Module 5, I already completed 2 chapters. Now in the third chapter also have done some topics. Today we will see one of the topic in Bode plots. I've already completed basic factors of G of j omega and H of j omega. In this video, I'm going to cover the general procedure for constructing Bode plots. How to construct the Bode plot. The general procedure for constructing Bode plots consists of some sequence of steps. That is, the following steps are generally involved in constructing the Bode plot for a given G of j omega and H of j omega. First, what we should do, rewrite the sinusoidal transfer function as a product of basic factors of time constant form. Nothing but in the form of j omega we should write. Identify the corner frequencies associated with each one of these basic factors. Like corner frequencies, how we have done, right? Like for the factors, the basic factors, same way we will find the corner frequencies based on the magnitude formula. Then once we know the corner frequencies, draw the asymptotic magnitude plot. We will draw the asymptotic plot. This plot consists of straight line segments with line slope changing. Same the way we have drawn now like this, and there is some slope like this drawn. Same way we are going to draw for a given transfer function g of j omega and h of j omega, and corner then plus 20 dB by decade for a 0 and minus 20 dB decade for pole. For a pole, for a 0 it is plus 20 dB by decade, and minus 20 dB by decade for a pole, that is plus or minus 20 dB by decade for a 0 or pole of multiplicity m. For a complex conjugate 0 or pole, the slope changes by plus or minus 40 dB by decade. So what you should remember here, main thing is, once you get to know the corner frequencies, what we should do, there is a slope present, and the corner frequency by what? Plus 20 dB by decade for 0 and minus 20 dB by decade for pole, and it is nothing but plus or minus 20 dB by decade with a for a 0 or pole with a multiplicity m. M is some multiplic value, either n, like it is multiple poles, no, like we have seen multiple poles at the origin, multiple poles like that. So n or m, in that place if it is 2 into 2 like that. Okay, for a complex conjugate 0 or pole, if it is a complex conjugate 0 or pole, the slope changes by what? Plus or minus 40 dB by decade. Okay, then fourth point, for the error graphs of 7.25, this is the error graph of 7.25, determine the corrections to be applied to the asymptotic plot. We need to determine the corrections to be applied, then draw a smooth curve through the corrected points such that it is asymptotic to the line segments. This gives the actual log magnitude plot. We should correct it, then draw the points, so it is asymptotic to the line segments, which is a log magnitude plot. The sixth step is what? Calculate the total phase angle of g of j omega, h of j omega at different frequencies and plot the resultant phase plot. We need to draw the phase plot also by the total phase angle at different frequencies, and that is nothing but phase plot. Okay, these are the steps we need to follow for constructing Bode plot. To illustrate the technique, the whole 6 points, we will take a small example. That is the transfer function. What it is? G of s into h of s, that is equals to 54 into s plus 4 by s into s plus 1 into s square plus 1.8 s plus 36. If you see, this 54 is, this is nothing but k. That is what? The open loop gain it is. Okay. So the given transfer function is in pole 0 form. It is in the pole 0 form, but because zeros are also present, poles are also present. Every time numerator will be poles, denominator are zeros. Converting into time constant form, we have what? G of s into h of s, 54. If you take 4 outside, 4 as common, you will get by 1 plus s by 4. Okay. Then s into s plus 1 into 36 if you take common, then 1 plus 1.8 into s by 36 and s square by 36 you can write. Then what you can do here is, if you cancel it here, 4 nines and 9 sixes, 54. So you are left with what? 6. So 6 into 1 plus s by 4 by s into 1 plus s into 1 plus 0.3 into s plus s by 6 plus s by 6 whole square you can write. Anyway, 6 square is what? 36. So s by 6 whole square you can write. Therefore, the final sinusoidal transfer function of time constant form. Time constant form means what? Is that it should be in the form of 1 plus form. 1 plus s, 1 plus, like this it should be. Okay, time constant form. Okay, 1 plus s tau. No, it should be in this form. So when it is in this form, what you can do? You can convert into what? Sinusoidal transfer function. Nothing but substitute s is equals to j omega. The way we do. When you put j omega, what happened? 6 into 1 plus j omega by 4. J omega into 1 plus j omega. 1 plus j omega, j 0.3 into omega by 6 minus omega by 6 whole square. Why minus? Because in the place of s, if you put j omega whole square by 36, what happens here is minus j square is what you got? Minus 1. So minus 1 into omega square, omega by 6 whole square. So what happens? Minus omega by 6 whole square is the final one. Okay. Once we are done with the j omega we have written, no, the equation, we can write the asymptotic approximation table construction of the, for the construction of the Bode plot. How we can do is, for factors, first we will expand this equation in this way, that is 6 by j omega. This separately you can write now as it is multiplication. Then again you can write 1 by j omega, 1 plus j omega and 1 plus j omega by 4, and one more you can write 1 by j, 1 plus j into 0.3 into omega by 6 minus omega by 6 4. We can by part, like we can divide like this, right? If we do like this, then what you can see, first one you can write as one of the factor. For this, corner frequency is none. Corner frequency, how you will calculate is, if you see here, um, uh, corner frequency here it is as here it is integrator, the corner frequency is none. Okay, then a straight line slope of minus 20 dB is drawn for dB by dB by decade. So as it is the integrator, if you remember the basic factors, from that this is written through the 20 log 6 15.56 dB point at omega 1. So the constant will be minus 90, same as integrator what we see in the basic factors. And the second factor is what? 1 by 1 plus j omega. As this, if you see, it is in the form of what? First order low pass. The omega will be what? 1. Here it is, the omega is what? 1. Why? Because this is nothing but corner frequency. This corner frequency, omega will be less than omega 1, then what it is? It is a straight line, that is 0 dB. Then if its omega is greater than omega 1, it is a straight line with a slope minus 20 dB by decade. Same like what? The first order low pass. Phase angle varies from 0 to minus 90. Why? Because if you see, if omega is less than 1, it is 0. If omega equals to 1, it happens what? Minus 45 you will get. And when omega is greater than 1, then it becomes minus 90. So it is, angle is varying from 0 to 90. And when omega is equals to omega 1 equals to 1, the phi will be what? Minus 45. Okay. How the phase angle is found? Minus tan inverse omega. Minus tan inverse 1 if you take, nothing but 45, no, tan 45 is 1. Okay, so you can write as 45. Then 1 plus j omega by 4. Then omega 2 equals to what? 4. Why? Because the corner frequency here is 4. So same way, for like this only, if you write, when omega is less than, it is 0 dB, and omega is greater than omega 2, it is a straight line with a slope of plus 20 dB by decade. Okay, then you can write the angle, it is varying from 0 to 90, plus 90 here, not minus 90. minus 90, and at omega equals to omega 2 equals to 4. Okay, when it is 4, the phi will be what? Minus 45. Just correct it. Here it is minus 45. Minus 45. Minus 45. It is not plus here. It is minus 45. Then same way, last we are left with what? Second order system. From second order system, you know that this is omega, that is nothing but what? 6. 6 is the omega 3, and that is the corner frequency. And y, how we will find? It is 0.15. 0.15. From this equation, if you calculate what the xi value, you can get 0.15. So the same way here, the phase angle varies from what? 0 to minus 180 degree, and omega equals to omega 3 equals to what? 6, and phi is what? Minus 90 degree. So this, in this way we are going to find the phase angle. Okay. Then the resultant magnitude plot is shown in the figure 7.27. If you see here, we start with a factor fixed j by j omega corresponding to the pole at the origin. Pole at the origin. Okay. Then its log magnitude plot is the asymptote one. See, here it is. Okay, asymptote one. Then a straight line having a slope of minus 20 dB and passing through a point 20 log 6, that is 15.66 at omega equals to what? 1. This will be the resultant plot up to the next corner frequency omega 1 equals to 1. Then let us now add to the asymptote 1 the plot of factor 1 plus 1 by 1 plus j omega corresponding to the lowest corner frequency, that is omega equals to omega 1 equals to 1. Since this factor contributes 0 dB, and for omega less than 1 equals to omega 1 equals to 1, the resultant plot up to omega 1 is same as that of asymptote 1. For omega greater than omega 1, it becomes what? Minus 20 dB. Minus 20 dB. Minus 20 dB you will get. Okay, after minus 20 dB decay such that the resultant plot of these two factors is the asymptote 2. The resultant minus 20 here, again minus 20, so minus 40 it will become asymptote 2. Okay, so minus 20 plus minus 20, that is minus 40 dB by decay. This will be the resultant plot from omega 1 equals to 1 up to next corner frequency omega 2 equals to 4. The next corner frequency is what? Omega 2 equals to 4. Now let us as asymptote 2 the plot of factor 1 plus j omega by 4 corresponding to the corner frequency 4, and since this factor contributes that when omega is less than omega 2 that is 4, the resultant plot is omega equals to 4 is the same as that of asymptote 2, it will be same. Then when omega is greater than omega 2, that is equals to 4, plus 20 dB will be there. So when minus 40 is given with the plus 20, you are again left with what? Minus 20 dB at asymptote 3. Asymptote 3. Again next, this will be the resultant plot when omega corner frequency is 4 till the next corner frequency, that is 6. When it comes in 6, when omega is greater than omega 3, that is equals to 6, the magnitude plot of this comes into effect and is added. So this factor gives to rise of what? Minus 40 dB. Minus 40 dB it is going to give. So which when added to the asymptote 3, when it is added to the asymptote 3, minus 40, you are left here with minus 20. Minus 20 plus of minus 40, you are left with minus 60 dB asymptote 4. So since there is no other factor, resultant plot continues to infinity. Till infinity it continues like this only. Understanding? In this way we are going to, and here the phi is phi values have been written, that is 45 minus 180, like that they are that is also plotted. To the asymptotic plot thus obtained, corrections are to be made to get the actual plot. dB corrections are made at the corner frequency and twice and half its value. Corrections contributed by the adjoining corner frequencies are to be added algebraically. We'll see that phi equals to angle of this you will take, no, the angle of the equation what we got, that phi equals to, what is the value we need to take, minus 90 minus tan inverse omega minus tan inverse 0.3 omega by 6 by 1 minus omega by 6 whole square plus tan inverse omega by 4. You should write in this way. Then the resultant phase at various frequencies is calculated and a smooth curve is drawn passing through these points. When omega equals to 1, you will get phi value. This is a formula where, okay, is the formula where you need to calculate for omega 1, omega 4, omega 5, 5.56 just for the correction passing through all the points. You will get some degree values. That degree values you are going to correct it for the smooth curve. Once the magnitude and phase Bode plots are drawn, magnitude is done and phase Bode plots are drawn, we can determine the absolute and relative stabilities of the system from these plots. Gain crossover frequency means what? The gain crossover frequency, omega g, is defined as the frequency at which the resultant magnitude is what? 0 dB. The gain crossover frequency is defined as the frequency at which this is equals to 1. And phase cross frequency, what? The phase crossover frequency WP is defined as the frequency at which resultant phase is what? Minus 180. And the phase crossover, that is nothing but the phase crossover frequency is defined as the frequency at which it is minus, angle is minus 180. So gain margin means what? Is a measure of relative stability of a system. It is defined as the amount of additional gain that should be added at the phase crossover frequency to bring the system to verge of instability. So gain margin is always positive for stable control systems. So gain margin should be positive for stable control systems. Then phase margin. Phase margin is also a measure of relative stability. It is also relative stability. It is defined as the amount of additional phase lag. Here is additional gain. Here it is additional phase lag that should be added at the gain crossover frequency to bring the system to the verge of instability. Phase margin is always positive for the stable control system. You need to remember two things here. I will say the differences here. Gain margin is also relative stability of a system measures, and here also it is relative stability. The difference what you should find here is, it is defined as the amount of additional gain that should be added to the phase crossover frequency. That is nothing but gain margin. Here additional phase lag should be added to the gain crossover frequency. The system to verge the instability. So to not become instability, what we should do? The gain margin and phase margin should always be positive for stable control systems. Understood? So this completes the general procedure for constructing Bode plots. I'll stop the video here. We will, the next video will be on the topic computation of gain margin and phase margin. For now, I'll stop the video. Thank you from Sri Sai Tech Edu YouTube channel. Read, lead, success. Keep reading.